what we call exaggeration. Exaggeration. Once bleeding out, what will happen is energy completed, or we say, we're using a name, we call it depleted. So what happened is there's no ATPs. Okay? Then, in the body, there's always something storage there. There is a polysaccharide storage in the liver, which is called glycogen. It's a polysaccharide. The glycogen in the body, after the energy depleted, after exaggeration, it's immediately we're going through a process we mentioned, glycolysis. And coupled with fermentation. So what kind of thing will generate? Is lactic acid or other acids. Okay, once this acid created, what will happen? Two things. Number one, the pH will decrease from 6.7, 6.8 to 5.5, ideally. Now remember this curve? What we have to avoid? 5.0. Because at that moment, water holding capacity is lower. That also we call it an isoelectric point of a muscle. Generally speaking, 5.0. Of course, different muscle have a different one. Okay, so we call it the IP, or we say it's a PI point, right here. So first of all, pH will be decreased. The second thing what will happen? Active myosin cross bridge, because there is no ATP there. Ideally, theoretically, so what happened? The cross bridge will have. So, actin myosin cross bridge will create it. Okay, once they created, what happened? The muscle become tough. This we call rigor mortis. Acronym RM. So, we want to talk about this rigor mortis, what this means. Okay, number 6. OM. What happened for the OM? First of all, what does rigor mortis means? This coming from Latin words, which means stiffness of this, or toughness after this, which means after this, the muscle will be tough. Everybody knows. However, it's not happened immediately. Then come also with an interesting, very typical curve in the science area. What's a curve looks like? The curve everybody knows and looks very similar. The curve looks like that. The x-axis is time. Y-axis is shear force value, SFV. Okay. Oh no, not like this. I forgot. Not draw this correctly. They should have a one. Somehow like, let me think about it. Somehow like this. Sorry. It's like this. Okay? Now, we want to talk here. 3 section. This point, onset. This is rigor mortis point. Last section, resolution. Okay. Here is something we want to say. A carcass is slaughtered. The bleeding is gone. Ideally, the energy is depleted. However, in the body, you have some residue. Energy will be created. Why? Because ADP could working with creatine phosphate generate ATP. This is very temporary. And in a different animal, this time is different. That's why you see the curve right here is pretty flat at the beginning. We call it onset time. Onset time depends on different animal. Beef, longer, 6-12 hours. Pork, pig, little bit shorter, 3 hours. Chicken, very short, less than 0.5 hours. Fish, very short, less than 0.5 hours. This comes out something important. Because the onset time of chicken is very short, so chicken we can do chilling, but we cannot do chilling for the beef. Will cause cold shortening. That will give you very tough muscle. Okay? So, this is at the beginning. Then, this is temporary. So muscle can still relax. But once this is gone, there's no ATP. Started to have a rigor mortis. So it becomes a muscle. The shear force value is increased. At this point, the rigor mortis is completed, which means the muscle is very tough. Then how come later on it's also decreased? How come the muscle gradually become less tough? We call it a resolution. The reason is, we go back to here. We talk about the actin myosin cross bridge is here. Is here. But remember what I said. Surrounding the Z line, there are multiple proteins. These will start to degrade it. You can understand these proteins hinged the Z line, they started to loosen. This is because prolytic reaction causing degradation of proteins surrounding the Z line. Now, what are those proteins? Is nebulin, desmin, and titin, and lots of others. Now, why they can do that? Because they rely on an internal enzyme of a skeletal muscle. Okay, what is the name of this internal enzyme? Yes, calpain. Then calpain rely on what? Rely on concentration of calcium. Therefore, there are two different types of the calpain, which is M-calpain. That rely on is relatively lower concentration of the calcium. It is about 0.5 to 1.5 millimole calcium. There is also called mu calcium or calpain. That rely on a huge amount of the calcium compared to the M calpain. That is usually 5 to 50 micromole of calcium. Okay, now then the question. The calcium, we said, the calpain, we said it's an internal enzyme of a skeletal muscle. So, it really depends on the cattle itself. Therefore, come out with a very important question. You talk about breeding. We talk a little bit. So why it is important? Because in our body, in the beef cattle's body, they have a calpain. But at the same time, they have a calpain inhibitor. The inhibitor names calplastatin. Okay, this goes you some of the common knowledge. When you go to order a beef steaks in the restaurant, you always order what? Did you order Angus? You said Angus beef. Okay, medium, well done, let's say. Okay, why Angus? Because their calpain inhibitor is very less, it's minimal. But I want to tell you one thing, the key thing is that you do a different breeding. So in the United States, that some of the students tells me their family is doing those business. When you get the Angus steaks, it's not 100% Angus. It's sometimes breeding is 25% of Angus. They can label Angus. The reason why Angus will give you a very tenderized beef because the calpain inhibitor calplastatin is very low amount. Then, in the opposite way, there is another cattle called Bos indicus. That calplastatin is huge. This gives you called Breham cattle. This Breham cattle, the breeding is founded by Dr. Zim Palmer. He was was a professor at the University of Florida back in 1910s. In this cattle, they find that the muscle is extremely tough because there are huge amount of calplastatin. So completely inhibit the calpain, which means this internal enzyme is completely inhibited. So this doesn't work very well. Okay, Angus we know it's for eating, the tenderized beef. Then what's Bos indicus going to do? Back in 1910s, do we have a truck? Do we have like a car or those and a farming facility? No. So this is a farming animal. So that's a story behind it. This is the whole thing. It looks like a system. Okay. Okay, we get. I'll talk 3 more minutes. Okay. So that's what happened. Now, these days they have a lot of the technology. You can buy a powder, a bag of powder, said it's a tenderizing powder during the beef steaks preparation. Or you can buy some of the made chemicals, can do a beef tenderization. The idea of behind that and the major components of that powder is calcium. So you can manually adding calcium during post-harvest storage, because the calcium will activate the calpain. Even the animal is killed, the calpain is still active. They can break down right here. because you can do nothing for active myosin cross bridge. They can do work very hard in here, and some of the plant-based enzyme can do the same thing as a calpain, which is externalized, we added. That's the reason. Okay? Now, during the history, when people talk about the structure of the muscle, talk about the contraction, relaxing related to beef tenderization, they have a problem generated, which is called cold shortening. This we'll talk next week. Okay? So, not done yet. It won't finish in one class. We going through here is a big picture for meat tenderization. We talk about tenderization is important because 50% of consumers in the United States want to tenderize the beef. Then we need to talk about the muscle structure. The key thing here is active myosin cross bridge and the protein surrounded the Z-line, which is the edge of a muscle unit sarcomere. So then we go over, we talk about how the carcass becomes the meat, relate to muscle contraction, relaxing, relate to the rigor mortis, but the key thing here is the calcium components, is the calcium concentration. That is play a much important role later on for the tenderized beef. Even this cold shortening is also related to the calcium dramatically released from the sarcolemma reticulum. Okay, so we're gonna have left something we'll talk. We are gonna go over these real quick. Next week Tuesday, then we go ahead to talk about the left cold shortening and other things. Then, related to the beef tenderization, we will talk about three things, which is PSE and DFD, which are two major issues happening in the meat industry because of low quality beef and pork. So those things we want to cover next Tuesday. Okay? So that's what we have.